Hello everyone, welcome to the long overdue video on going through the 2024 Deferred Maths paper 2. So I did go through the Deferred paper 1. That video did do quite well. And I'm going to be doing just the exact same, but this time for the paper 2. So let me actually fetch my calculator because it's not actually on my desk. As I said, I'm doing these questions live, so I am just going to fetch my calculator from across my room. And also turn my phone off while I'm at it. Okay, so calculator in hand. It's the classic Casio FX83 GT. So Brill. And the starting time is 14:15. Okay, let's go. So, question AI, find the midpoint, or write in the midpoint of PQ. Okay, should be relatively straightforward. I'm going to call the point S. So I'll say that S is the average of the two x coordinates over 2, and the average of the y coordinates over 2. So that's 10 over 2, which is 5, and 2 over 2, which is 1. Also, do excuse if this is particularly a laggy video. I'm actually having to charge my laptop while I'm doing this. So hence or otherwise find the equation of the perpendicular bisector of the line segment PQ. Okay, so I'll first calculate the slope of PQ. So the change in y be 5 take away minus 3 all over 6 take away 4. So that's 8 over 2, which is 4. So that implies that m perp is minus a quarter. Now it also goes through the 0.51. So we'll use the y minus y1 equation to say that y take away 1 is minus a quarter, x take away 5. Now, this kind of can be written in different forms. So this is technically an equation of the bisector. I'm going to throw everything to one side and let everything equal to 0. So 4y take away 4 is minus x plus 5. So x plus 4y minus 9 equals 0 is the equation of the bisector for PQ. Hence, find the coordinates of the circumcenter of PQ are, that is, the points where perpendicular bisectors of the sides meet. Okay. So effectively what we have so far is this line going like that. So now I'll do QR as the side to pick next. So the midpoint, which I think for kind of all intents and purposes being consistent, I'm going to call it T. So it'll be 10 plus 4 over 2. Added to that, well, it's going to lie on this, so it's going to be minus 3 take away minus 3 over 2, which just becomes minus 3. So 10 over, or 10 plus 4 is 14 over 2 makes 7, so 7 minus 3. Now, the slope of it's not going to be that great. It'll just be a line going through T, which will just be the line x equal to 7. So the line, so that's kind of perpendicular to QR through T, is just the line x equal to 7. So the bisector will kind of lie somewhere on the x equal to 7 line. So it might look a bit like that. So if x is 7, then we can sub that into the other perpendicular line. So 7 plus 4y take away 9 equals 0. 9 take away 7 is 2, so 4y is 2. So that further implies that y is a half. So the coordinates of the circumcenter are 7, 1 half. Okay, the line AB intersects the x-axis at A and the y-axis at B the point minus 6, 2 is the midpoint of AB. So draw a diagram as always. We have AB intersects the x-axis at a point A, and y-axis at B, but also minus 6, 2. So the line might look something like that. So this point is A, and then this point is B. So if it goes up 2 and across 6, so that's 2 and that's 6, then this has to be 6 and 2 as well. So B will just be minus 12, 0, and A will just be 0, 4. Perfect. Okay, next question. The circle S is center 2, 4, and the point minus 1, minus 3 lies on S. Find the equation of circle S. Okay. So we know it'll be x take away 2 squared plus y take away 4 squared is some r squared. But r squared is just the distance from the center to the point. So r squared will just be the change in x. So 2 to minus 1 is 3. And 4 to minus 3 is 7. So it's 49 to 9, which is 58. So what we could say is that S has the equation x take away 2 squared plus y take away 4 squared. Which I'll just write r squared is 58. So that ends up being 58. And that's the equation of S. The circle of center that and the point that, use the diagram on the right or otherwise to write down the coordinates of 2 of the points that lie on circle C. Okay. We could really kind of do anything here. Well, it's kind of just the same thing. So we need to actually just find that radius first. So it'll be x take away 9 squared plus y take away 2 squared equals r squared, but r squared will just be the change in x, so 6 squared, plus the change in y, which is 4 squared. So that's 36 at 16, which is 52. So r squared is 52. So I'll have the equation x take away 9 squared plus, y plus 2 squared equals 52. So now we'll just kind of pick any values we want. Let's just say, I don't know, we'll set x to be 9. And we'll find the corresponding value of y. So we'll have 9 and 9, and we'll get 2 values of y just to make that thing disappear. So we'll get y plus 2 squared is 52. So y plus 2 is plus or minus root 52. 52 is 4 times 13, so it's actually plus or minus 2 root 13. So that implies that y is minus 2 plus or minus 2 square roots of 13. So I'll have one of them as minus 2 plus 2 square roots of 13, and minus 2 minus 2 square roots of 13. Okay. The circle K has its center in the first quadrant. The y-axis is tangent to K at the point 03. The circle K intersects the x-axis at the point G and H, with the distance between G and H being 8. Okay. Let's define the equation of the circle K. Doesn't tell us the radius, but it does tell us G and H. Okay, well, if I kind of draw a radius down here and then kind of 2 radii joining here, we can use the fact that there's a chord here, so these 2 radii will bisect the chord. If G to H is 8, then that's 4 and that's 4. So both of those side lengths are 4 long. So those are the horizontal line segments. Okay. Then this distance here matches this distance here. So this distance is actually 3. And this side distance is 4. So that radius is 5. Okay, brilliant. So if we kind of match from here, it will have its center as something 3, but oh, this distance is also 5. So its center will be 5, 3. So k therefore has the equation x take away 5 squared plus y take away 3 squared is 25. That is the equation of circle K. Not to be confused with the petrol station. Okay, I can't actually do the construction stuff because I'm working on a laptop, so this question will just have to be skipped. People who know how to draw this, they should be okay enough with it. But I don't have a compass and ruler, and I can't really approximate it, so I'll leave that question out for now. Circle circumference of 30, work at the area in cubic centimeters. Fair enough, in terms of pi. So 30 is just 2 pi r. So therefore the radius will just be 15 over pi. So that implies that the area is pi times 15 over pi squared. We'll get a pi over pi squared, so it'll be something over pi, and 15 squared is 225. It took me a while to work out. It's 225 over pi square centimeters. Oh dearie me. Okay, I don't like these angle questions. So, always the center of a different circle. A and B are points of the circle as shown in the diagram. Okay. The chord AB is extended through B to C. So the chord AB is extended to C. Yep. So that BC is equal to the radius of the circle. Okay, so these two are equal, and so is this. Okay, CO intersects the circle at D, it does, with E, and D is an element of the line CO. Okay, that the angle BCO equal X, work out AOE. Okay, so that angle there is X. Work at the angle AOE. Oh, this one here. Okay, so this is our angle we have to figure out. So a couple of things we can work with. This angle is also X because it's isosceles. And the angles on the triangle have to add up to 180. So this angle in here will be 180 take away 2x, because if we add the 2, we'll get 180. And we can, I guess, work that this one here has to be 2x, which then furthers it so that this has to be 2x. Okay, so this angle in here, again, AOB is a triangle. I should actually be writing all this down, actually. So BOC is the same as BCO because they're isosceles. So that implies that the magnitude of the angle CBO is 180 take away 2x, as angles in triangle add to 180 degrees. Okay, so the angle OBA is 2x, since angles in a straight line add also to 180 degrees. And the BAO is equal. So BAO is equal to OBA. Again, because it's an isosceles triangle. So then we can work that BOA will be 180 take away 4x. For again the same reason as above, so I'll just mark star, star. So therefore, this angle here, 180 take away 3x, so this has to be 3x. 3x plus 4x take away. So that implies angle AOE is 3x, again, by that. Now, 180 minus 4x, that should actually be something else. So I'll mark that as T instead of an asterisk. Okay, question number 4. Find the value of cos of 105 without using a calculator. Give your answer in that weird form. No bother. So this is kind of one of the numbers you should memorize as 60 plus 45, just to make it easier, and then do the cos addition formula. So cos of A plus B is cos A, cos B, take sine A, sine B. That's not charged enough. Okay. So cosine of 105 is cos 60, cos 45, take sine 60, sine 45. Cos of 60 is a half, and cos of 45, how will I write this? I'll write it as 1 over root 2, because we'll get root 2's popping up on the bottom, so I think that's probably best. Take away sine of 60 is root 3 over 2 times again 1 over root 2. And perfect, we can get a factor of 2 over root 2, or 2 root 2 actually, down the bottom. And then we'll get 1 take away the square root of 3 on the top. So if I know your pedantic, A is 3 and B is 2. Okay, another kind of general proof. This one I can actually do. So sine of A plus B is sine A cos B plus cos A sine B. And then we'll just let B equal to A. So we can make it as sine A cos A plus cos A sine A, which is two lots of sine A cos A. So it's a proof, so QED. Okay, the triangle ABC is shown below. AB is 5, AC is 3, angle ABC is equal to W, and angle ACB is 2W, where W lies between 0 and 45. Find the value of cosine of W in the form P over Q, where P and Q are natural. Just have a bottle of water next to me. Okay, well, normally you'd probably want to do the cosine rule, but we don't actually have this third side, so I think I'm going to do sine rule and see if I can get sine of W somewhere popping up. So 3, or actually I'll write it sine of W over 3 equals sine of 2W over 5. And this is 2 sine W cos W, so we actually get things cancelling. So sine of W over 3 is 2 sine W cos W over 5. So the sine W's cancel. We can do that because this will never be 0, just looking at the domain. So how are we? Well, actually this is relatively straightforward. We can just write cosine of W as 5/3 over 2, so 5 over 6. Again, if I want to be pedantic, P is 5, Q is 6. Oh, cos W is 5 over 6. Okay, a statistics question. Haha. The margin of error for a certain population proportion is 1 divided by the square root of n. Surveys carried out on a random sample of 1,600 people find a margin of error based on that sample. So it's really just 1 over square root of 1,600. I know this is going to turn into 1 over 40, but I just want to double check and get it into a percentage form at least. 2.5%. Awesome. At sample size, you need to give a margin of error of exactly 1%. So 0.01 is just 1 over the square root of n. So root n is 1 over 0.01. So if I square both sides, 1 over 0.01 squared is 10,000. Brill. A, B, C, D, E, F are 6 events. A and B are independent. Standard thing. So if they're independent, the probability of A intersect B is just probability of A times probability of B. So 0.2 times 0.3, which will just be 0.06. Well, C and D are not strictly independent, so we can work that the probability of C union D is the probability of C as I go, plus the probability of D minus the probability of the two of them together. So that's the probability of C plus the probability of D, take out the probability of the two of them happening together. So it's 90 take away 8 is 0.82. E is not F is dash, and P of E intersect F X. Find out which probability of E given F is a quarter. Okay, so this is kind of a Bayes theorem, I think that's what it's called. I haven't actually looked at this in quite some time. So P given F is the probability of the two of them together divided by the probability of the second one. Okay. So we know that that's a quarter speak. So 1/4 equals the probability of E F is X, all divided by the probability of F, which is just X plus 0.4. So should be written implies here. So 4x is x plus 0.4. So 0.4 equals 3x. So x is just 0.4 over 3, which is 2 over 15. Okay, question 6. 7-letter code is made using A, B, C, D, E, F, G. Very inventive with what they call things. How many such codes are there? Well, if there's no restriction, it's 7 factorial. Where's the factorial button on this? There it is. 5040. And how many of these codes are the two vowels A and E together? So we can essentially treat this like A and E are kind of in their own bubble, and then B, C, D, E, F, G. So there's 6 factorial ways of organizing the block, or organizing the letters, but 2 factorial ways of organizing the block. So it'll just be 6 factorial times 2, which is 1440. Okay. Oh, it's another one of these ones. The mode of 6 positive numbers is 2. The median is 5.5. Find 6 such numbers that have the smallest possible mean. Okay. Well, I can immediately work out, because there's an even number of them, these two would probably have to be 5 and 6. If the mode is 2, then these have to be 2. Yep, so the median is that, so they kind of have to stay there. So we'll pick... well, it can't be 6, because then it would clash with the mode there. Can't be 7 either, because that clashes as well. So it'll just be 7 and 8. So x bar is just 2 plus 2 plus 5 plus 6 plus 7 plus 8. All over 6. 2, 4, 9, 15, and 15 is 30 over 6 is 5. Why does it keep doing that? Behave yourself. So that's 30 over 6, which is 5. Brill stuff. Okay, finally on to section B, thank God. So, Phi owns a forest. The height of trees in a forest of this type are usually normally distributed. The mean height of 360 and a standard deviation 27. One tree. And probably the tree this height is between 330 and 390. Okay, so first thing to note is, well, we'll actually write down that that mean, or yeah, it is the x takeaway mu, so it's 360 with a standard deviation of 27, both in units of centimeters. So they're equally spaced from the mean. So that means the z score will just be plus or minus in that case. So z of at least the positive one will be 390 take away 360 all over 27. Which is 1.11. So how are we going to work this? I need to actually get log tables. So okay. My iPad's literally on my bed, so I'm going to check what the probably of z being less than 1.1 is. But kind of to demonstrate that, we're going to be in this region. So it's the probability that z, actually, so the area is the probability that z is less than or equal to 1.11, take away the probability that z is less than or equal to minus 1.11. But that's 1 minus probability of z, so that's just, how's that going to work? It'd just be 2 times that. I think it's just 2 times the probability of z less than 1.11 minus 1. So log tables to find these z scores. There they are. Okay, 1.11 is 0.8665. So 2 times 0.8665 minus 1 which is 0.7330. I'm including the 0 because it's kind of typical to include statistical stuff to 4 decimal places. So 0.7330. So the shortest, smallest 5% of trees in the forest are not sent to the factory. Saying on 12, what's the minimum height that a tree needs to be in order for it to be sent to the factory when the forest is harvested? Okay, so I mean, there's that distribution again. So we want essentially this area is kind of the area that we're kind of not considering. So this is kind of that minimum value. So, So the probability that z is less than some capital Z has to be 0. Well, if it's the smallest 5%, it'd be 0.95. So that's considering it up, but now we need to consider it going back. So I'm going to look in the log tables for one of those values. So one that gets kind of closest to 95, which is 1.64. So we have that z in this case will be minus 1.64. So since probability z less than or equal to 1.64 is like roughly 95%. So minus 1.64 would be the smallest 5%. So that implies that minus 1.64 is x take away 360 over 27. So this should be relatively simple. 27 times minus 1.64 and then plus 360. Does it say specificity? No? Okay. So 315.7 centimeters. If I want to be consistent with the unit base in the question of it using centimeters. Okay, Fia claims the mean height of the trees in her forest is different to the usual height because they become infected. Takes 100 trees at random from her forest, measures their height. The mean height of this sample is 350. Test the yeah, okay, that's fine. So the mean height of the trees is 360. So the alternative would be that the mean height of the trees in Fia's forest is not 360 centimeters, in this case within 5% significance level. So what are we given? Well, the usual height is 360, so that's kind of our population mean from before. Our sample mean is 350. Standard deviation, I presume, is the same, and the number is 100. So we're going to be doing a z-score test here. Actually, I'm just going to double check that I am still recording. It's okay. Yep. All right, all good. So yeah, we're doing a z-score calculation here. So z will just be x bar minus mu all over sigma over the square root of n. So 350 take 360 all over 27 over square root of 100 is just 10. And we get z as minus 3.7, which in itself is very much less than 1.96. So what we can say is, in our conclusion, we reject the null hypothesis. So that would imply that the mean height is actually different. So it's not actually 360 centimeters within the 5% significance level. So the reason for the conclusion is that minus 3.7 is less than minus 1.96, negative 1.96. So it is outside of the critical region, which is between minus 1.96 and plus 1.96. And actually I should be not including greater than or equal to signs because they're kind of redundant. The number of trees are infected with the disease picks for sample 160 trees and examines them, and 48 are infected. Okay, so this is a p hash kind of distribution, not distribution, but question. So p hash will just be the amount that are affected, so 48 over 160, which I presume it is a nice number because they're both multiples of 6. Yep, so 3 over 10. That's p hash. And our error margin is, well, it'd just be p hat plus or minus 1.96 root p hat 1 minus p hat over n. So it'll just be p hat minus e and then p hat plus e. So I think I'll calculate what this bit is. So it'll just be 0.3, which I think I'll just write this as plus or minus 1.96 root 0.3 times 0.7 all over the sample number, which is 160. So that should be 1.96. So 1.96 times the square root of 0.3 times 0.7 over 160 is 0.0710. So it's 0.3 plus or minus 0.0710. So that implies that the p hat lies within the following region. It's either 0.3710 or it's 0.3 take away 0.0710, which is 0.2290. So that's that 5% or 95% confidence level. So 95% confidence level means in the context of the question. So that's just ooh, I was thinking of something else, but the 95% confidence level is that we can essentially say that 95% of the samples will lie within the region. There's just below a normal curve with a mean of 360. On the same diagram, draw a new curve that has the same standard deviation as the given curve, but a mean of 350. So it's really just kind of shoving this graph across. So kind of just look a bit like that. The diagram below shows the same normal curves above mean that. I'll draw a new curve that will have also mean of 360, but that will have a smaller standard deviation than the given curve. So a lot of it will kind of be closer to the mean. So I'll kind of make this a bit steeper. And we'll go like that. Okay, question 7 is finished. And we're doing alright for time. I started this a quarter past. I'm probably not get this done under an hour because I never get paper 2s done in under an hour. But also I'm orating a lot of this, so a lot of it's kind of in my explanation. So Henrik has a farm, good for him. The diagram shows one of Henrik's fields in the shape of a triangle ABC. Area field, okay. Area field A is 1/2 AB sine of gamma. So it's 1/2 59 times 47 sine of 28 degrees. So 1/2 59 47 sine 28. To the nearest square meter, it's about 651 square meters. Work out the length of BC. Correct to 2 decimal places. Well, it's going to be cosine rule here. Jesus Christ! Come on. So if I got this side C, then I'll obviously have to rename it after. So C squared, A squared plus B squared, take away 2AB cos of gamma. So C squared is 59 squared plus 47 squared. Take away 2 lots of 59 by 47 times the cosine of 28 degrees. Okay, my laptop's probably sufficiently charged, at least for the rest of this video. Oh, the charge is very hot. That's just physics for you. So now I'll just evaluate this. So 59 squared plus 47 squared. Take away 2 lots of 59 by 47 times by the cosine of 28. So that's C squared. So BC is just the square root of that to 2 decimal places is 28.16 meters. Okay, spectacular so far. Henrik has 2 balers, a square and a round baler. These are machines to pick up straw, make them into bales. Travels average speed of 8 kilometers an hour while it's baling from the fields. Work how many minutes this will take. So time will just be distance over speed. So time will be, well, if it's 8 kilometers an hour, if it's 4,800 meters, that's the same as 4.8 kilometers. All over 8 kilometers per hour. That'll give us in units of hours, so I'm just going to times it by 60 minutes per hour. So it's 4.8 by 60 over 8. It will take 36 minutes. Okay. The baler makes shapes in rectangular solids. It has that volume, correct to 3 decimal places. The ratio of the dimensions of the bale is 2 by 3 by 5. Find the dimensions of the bale, give your answer correct to the nearest centimeter. Right, so it gives us it in cubic meters. So I think what I'm going to do is I'll work with these in meters, then I'll convert everything to centimeters. So these are all, this is like 2 times some dimension, this is 3 times some dimension, this is 5 times some dimension. So what we could say is that the volume is just length times width times height, which, to be consistent with the question, length is 5x, width is 3x, and height is 2x, which we know is 0.415. So 5 by 3 is 15 by 2 is 30. So this is 30 x cubed is 0.415. So x is just 0.415 over 30. And then we'll take the cube root of that answer, which is about 0.24. Awesome. Now that is technically in units of meters. So the height, I'll kind of work back in order, will be 2 lots of that. So 0.48 meters is 48 centimeters. The width is 3 lots of it, so that's 72 centimeters. And then the next one is b times 5, so 100. Oh, it gives us. Wow, okay. The height is 48, width is 72, and length is 120 centimeters. Perfect. So this is the round bale. The height of each cylinder is equal to its diameter. The volume of a cylindrical bale is that. Work out the radius of the bale. Okay, so I think it's probably best to draw a diagram here. So let's just imagine that there's our bale. The height is the same as the diameter. So if this is of radius r, then this is of height 2r. So that's twice the radius. And we know that it's 2.78. So what we could say is that 2.78, 0, is pi r squared times the height, which is 2r. So we'll have 2.780 is 2 pi r cubed. So r cubed will just be, you can't work out this in my head, so I think I'll just divide through it by pi. So 2.780 over 2 pi. So that implies that the radius is just the cube root of that. Which to the nearest centimeter, that's given it in meters again. So that's, well, it gives 0.76 meters, but that's just 76 centimeters. Awesome. Oh dearie me, what is this? Henrik is tiling his patio. The tiles are square with a design made of circles. It's like this large circle inscribed inside of a square tile. 4 small circles equal side in there. The centers of them form a square, and each small circle touches 2 other small circles and a large circle, as shown in the diagram below. The radius of each small circle is 1 centimeter. Work at the area of the square tile. Well, ooh, this is gonna be quite tricky. I have to kind of stare at this for a second. So I think what would probably be nice to do is just kind of denote that this is the same as the diameter as one of the circles. So that is a 2 centimeter side length. So that's 2 and that's 2. Four small circles equal sides inside a large circle. The centers of 4 circles form a square, and each small circle touches 2 other small circles, and a large circle is shown. The square tile in the large diagram below. Oh, okay, I think I see what to do. So if we mark 2 points here, and it goes through the center of this, that's the diameter of the circle, because it will go through that center. So if we can work out what that is, well, this length is just going to be 2 root 2, because we have a square, so that side length is root 2 times the side length. And each of these is of length 1. So the diameter of the circle, the diameter of big circle, equals the side length of the square. Brilliant. So we know that that diameter is 2 square roots of 2 plus 1 plus 1 is plus 2. So the area is just length squared, the area of the big square that is. So the area is just 2 plus 2 root 2 squared. I mean, hopefully this gives it in a nice form. Oh, okay, when you square it out, it actually gives you a form of root 2's in it, which I think is how they want it. Yeah, a plus b root c. So 8, or not 18, it's 12 plus 8 square roots of 2 in units of centimeters squared. Oh, not cubed. It's definitely centimeters squared. So again, if they want to be pedantic, A is 12, B is 8, and C is 2. Okay, time for another water break. Nice. Ooh, scatter plots. Shows the height and weight of each player in a rugby team in meters and kilograms, respectively. One of the numbers is the correct correlation coefficient for the data, which is the correct value. Well, it's pretty strong, kind of lies close to whatever the line of best fit is, so 0.9. Strong, positive correlation. Draw the line of best fit by eye and use this line to estimate the weight of a rugby player that is 1.8 meters tall. So I'm going to have to be very, very loose with this. That's not even me using the rule. That's actually pretty accurate. So if we go to the 1.8, okay, it's nearly like bang on 90. So I'm going to write it as 90 kilograms as the estimate, which I'd say is fairly normal. Particularly rugby team usually miss 8% of the tackles they attempt. Use this fact for beyond B double. Assume all tackles are independent. Okay, grand. Given each answer correct for decimal places, find the probability that the fourth tackle is the first one that they missed. So it's 3 successes and then 1 failure. So the probability of success is 1 minus probability of failure. So it'll be 0.92 cubed as the successes times by the fails, so 0.08. And it wants it to 4 decimal places, so 0.0623. Find the probability that the team miss at least 2 tackles. So if it's at least 2, then that's the same as 1 takeaway. That probably that they miss 0. It's just reset itself. Okay, brilliant. Plus the probability that they only miss 1. So that, which I'll just call PAL2, equals 1 takeaway. So for P0, it'd be 20 choose 0 times probability of successes is none. That they miss at least 2. Okay, so the probability of missing 0 is the probability that they hit them all. So 0.92 to the power of 20 plus 20 choose 1 times 0.92 to the 19 times 0.08 to the 1. So 20 to 0 is 1, so it'd be 1 take away 0.92 to the power of 20. Well, let me type this properly into my calculator. So 20 times 0.92 cubed plus, no, the first one is 1. 20 to 0 is 1. So it'd be 0.92 cubed plus 20 times 0.92 to the 19 times 0.08. And I get a math error. Where am I going wrong? What if I do it separately? So 20 to 0 is 1. So 0.92 to the power of 20 is, well, for decimal places, it's just me 1 minus 0.1887 plus, and this one is going to be 20 times 0.92 to the 19 by 0.08. Why didn't that work? 0.3282. So that's one takeaway. 0.1887. Take away 0.3282. Come on, why is this calculator being so weird? 0.1887 plus 0.3282. There we go. Okay, because it's 0.4831. Jesus Christ. At a particular stage of the game, the rugby team will either score 7 points, 5 points, or 0. The probability of each of these is X, Y, Z. The probability of getting 7 points is 4 times the probability of getting 5 points. The expected value for the number of points is 1.155. Okay, so the probability of getting 7, so that's X, is 4 times the probability of getting 5. So X is 4Y. It'll probably turn into simultaneous equations at some point, so that'll be equation number 1. The expected number of points is 1.155. So E of our variable, which will just be X, Y, Z, is 1.155, which equals 7x plus 5y. But x is 4y. So from equation 1, 1.155 equals, well, that would be 28. So 7 4 is 28y plus 5y. So y is 1.155 over 33. Which is 0.035. X is just 4 times that. So 0.14. So Z is 1 take away 0.035 plus 0.14. So 0.035 plus 0.14. 1 minus that, we get 0.825. I think that's a 2. The rugby team must pick 3 forwards from a total of 7 possible forwards and different combinations of 3 forwards. Well, it'll just be 7 choose 3. Which is 35. Oh, my back's getting really sore. On Saturday, the coach picks 3 forwards at random from the 7 forwards. On Sunday, the coach picks 3 forwards again from the same 7. Find the probability that no forward is picked on both Saturday and Sunday. So the total number of possible forwards they can pick on the second day is 4 choose 3 out of 7 choose 3. Does that even make sense? Or we could say that it's 1 minus the probability of the same 3. Or no, we'd have to consider them individually, wouldn't we? I'm running with this 4 choose 3 over 7 choose 3 type nonsense. I don't know why I'm actually rolling with this. Where's NCR? There it is. 4 choose 3 all over 7 choose 3, which is 4 out of 35. Okay, question 10. Right, finally some trigonometric functions popping up. And I don't think I'm going to get this done in an hour. Okay, I never thought I would. Chloe is cycling about. Chloe cycles over a small nail. She keeps like at the same speed with the nail stuck in her front wheel. Okay. As it rotates, the height of the nail increases and decreases as given by that. Okay. So I'll switch my calculator to radians. And complete a table. Classic. So 30, take away 30 cosine of 5 pi times x. We're going from 0 to 0.8 in steps of 0.1. Why is it giving me a math error? Starting at 0, go to 0.8 in steps of 0.1. Why is it giving me a math error? I'm not sure why it's giving me math error here. I guess I'll do it manually. So it'll be 0, 30, then 60, so then it becomes 30 again. Then, well, what period is it going to have? Well, it's going to have a period of 5 pi over 2 pi, so 5 has 2.5. No, I thought I was going to cheat the system by exploiting the period of the system, but nope. I'll have to type these in manually, so 30. Or maybe I am right, and I'm just kind of missing a bit of maths here. Because I'm guessing that I'll just go to 30 and 0. Draw the graph of y equals ht for between those two values. So what values are 0? So 0, 0.4, and 0.8. And then it'll just go 30, 60, 30. So 30, 60, 30, 30, 60, 30. Kind of screwed up at the beginning of the graph, but it kind of gets there. The period of h, yeah, is 0.4 seconds. Explain what this means in the context of Chloe's front wheel. That's just the time for one full rotation of Chloe's wheel. The wheel's radius is 30. Work the distance in one rotation of the wheel in the nearest millimeter. Okay, spicing up the units here. Well, if it's going in one full rotation, it travels the distance of the circumference of the circle. So if this was kind of a wheel with kind of spokes in it, it would start here, it would go the whole way around and back to there. So that's just the circumference. So C is 2 pi times 30 centimeters is 300 millimeters. So that's just 600 times pi millimeters, which is to the nearest millimeters 1885 millimeters. Ooh, okay. Work out the speed that Chloe is cycling at. Well, if it travels 1885 millimeters for every 0.4 seconds, kilometers. Right. So I'll convert this into meters first. So 1885 millimeters is just 1885 10 to the minus 3 meters. So that's 1.885 meters, which is 1.885 times 10 to the minus 3 kilometers. Now 0.4 seconds, converting that into hours, will be 0.4 over 3600 hours, which is 1 point, well, no, I'll write it as a nicer way. It's 1 over 9,000 hours. So speed is the distance, so 1.885 by 10 to the minus 3, all divided by 1 over 9,000. So 1.885 10 to the minus 3, all divided by 1 over 9,000. Nearest kilometer an hour is 17 kilometers per hour. It gives it a 16.965, but of course, if it wants particular rounding, we do have to abide by that. Okay. The vertical height of a building is h. The base of the building is at O. A and B are two of the points. O, A, and B are on all horizontal ground. Okay. From the angle of elevation to the top of the building is 45. That is the angle from O to A to the top of the building. It's 45. So that is 45, and that's 30 from here. As a result, OA is H. Okay, grand. So work out OB in terms of H. So this is fairly straightforward. We have OB, it's that length there, of course. So tan of 30 is the opposite side, so H all over the side length OB. So OB is H over tan of 30, which if I just convert my calculator back into degrees for a second, so 1 divided by the tangent of 30 is square root of 3. So OB is square root of 3 times H. Does it give units? Units of meters. Okay, perfect. The distance AB is 120 and angle AOB is 60. Well, is that kind of not immediately obvious? Oh, this angle in here is 60. I thought it meant one of the other ones. So that angle in there is 60. And AB is 120. So this length here is 120. Using this information, use the triangle ABO. That's actually a curse word, my guys, so be careful, SEC, if you're planning to spread this to Australian Aboriginals. Work at the value of H, the height of the building. If your answer to me is correct in one decimal place. Right, are we given AO at all? So we have, well, actually, let me kind of draw this triangle out again, because this is, I can't do with my clutter diagram here. So that's 60. This length is root 3 times H. This distance here is 120. Okay. I think we'll just have to get this length here. So tan of 45 is H over OA. So tan 45 is 1. So this length here is actually H. Okay. That's what I was missing. So I'll just kind of mark each of these. So this is cosine rule. So c squared is a squared plus b squared. Take away 2ab cosine of gamma. So 120 squared is h squared plus square root of 3h, all squared. Take away 2h root 3h cosine of 60. A lot of calculator work here. So 14,400 equals h squared plus 3h. So that's 4h squared. Take away 2 root 3h squared times cosine of 60 is a half. So the 2's will cancel. And if I factor out a h squared, it'll just be 4 minus square root of 3. So that implies that h is 14,400 all over 4 minus root 3, and then that whole thing is again square rooted. And so 14,400 all over 4 minus root 3 square root to the nearest, no, it's the one decimal place, is 79.7 meters. Okay. Please let that be it. Oh, thank God. Okay, right. What time are we at now? 15:20. So I started at 14:15 and finished it by 15:20. So that's 1 hour and 5 minutes of working time, which I was really close to getting it under an hour. As I tend to get paper ones in under an hour, but paper twos I have never done. So that's the hopefully this time correct solutions to the 2024 deferred paper. If I have screwed up at all, I will put a comment down and I will pin it, just in case you're watching back the video and wondering where things came from. So that's it. Thank you all for watching.